record now. And I'm going to share my screen so we can go to this one, this 1.2. And this won't take long at all. Okay. I think pretty much everybody's back. All right, so we're going to talk about translations, and they're really easy. This just means the function has something added to the end. If it's added to the end, the translation of f of x is up. And you may not get it right now, but we're going to do plenty of examples where you guys will see that. F of x minus a is down, so if you subtract on the end, it's down. If you add to x, these are the ones that are different. Anytime you pull something out of parentheses, you're going to change the sign. So right now we have a plus a, but when we pull it out of parentheses, we're going to actually change it to a minus. So this is where we're going to get into that different vertex instead of 0, 0. X is a left-right movement. If you minus it, you're going to the left. When we pull this out, it becomes a positive a. On the x-axis would be to the right. Okay. So I know that doesn't quite make sense right now, but it will in just a minute. Okay. So all of these very first graphs from here over are all parent graphs. What that means is they're as simple as possible. So if you look at just 3x squared, that's exactly what we were just working with in the last unit. So there's no plus anythings on there. So the 3x squared is like this, like we've been working with, okay? That 3x plus 0 squared plus 0. Now what we're going to do is put new numbers in there, and you're going to tell how it changes that parent graph. So how did this U shape move? What happens when I add 3 to the end? So you guys see that all of these are adding 3 to the end. Nothing else. Nothing's happening with that x. So if they're all add 3 to the end, up here it says if you add to the end of the function, then you go up. Caitlin, I think that I switched them. So it's not, if you don't have these notes, if I screwed it up, it's okay. All you have to write is like if you write a couple of the equations, so like on this one, if you have just a piece of paper, 3 to the x, 3x, 3x squared, and 3 absolute value of x are all parent graphs. If you just write a couple of the examples, you'll be fine. You'll understand what it is. When we get to the next page, you'll probably want to write the equation or copy the equation down. You're not missing anything, I can promise you that. Okay, so this is just, all of these are not going to be a lot of writing. It's just showing you different examples. So if you go back and reprint them, it's not going to be a lot of writing for you. So plus 3 on the end means that we move up 3. And again, these couple are not going to give you as much because it's a bunch of graphs to look at and equations, but when we get to the straight equations, it becomes super simple. What are we doing on the next ones? All of the next ones, what are we doing?
Subtracting 4.
Subtracting 4. So go back up to your cheat sheet at the top. If we minus to the end, that means we're moving it down. And how much were we moving it down? All of them were subtract 4. Okay. That's it for the first page. Like I told you, it's going to go pretty quick. That's why I felt bad having to switch over to the Zoom. We could have got it all in there, but we didn't. So then we're going to look at these. And these are a little different because now where is this +4 at?
Inside the parentheses.
It's inside parentheses, or in this case, it's with the X. So all of these are with X. When it's with that X, you're going to pull it outside, treat it like it is parentheses. You're going to pull it out and make it a -4. So remember, X goes left to right, with left being a negative movement and right being a positive movement. So with the X's, you have to think backwards. I pull it out and make it a -4. Negative is a left movement. And then we did 4 units. So the X's are the ones you got to watch. Okay, but again, the more you do, the easier it gets. This will not be the hard stuff for you. What did we do on the next ones? What do we do to every one?
Subtract 3.
Huh? So when we pull it out, we're actually going to do what?
Move right 4.
So actually +3, which means we moved right 3. That is perfect. So now when you look at the next equations, they're all the same, except for you're doing 2 things rather than just 1. So on this row, what are the 2 things that you're doing?
Moving left 3 and down 2.
So there's your your left 3 and down 2. Why is it left 3?
Because you have to take it out and flip the signs.
Take it out and flip the sign. The end is normal. So left 3, down 2. Y'all, that's how quick it is. That's it. That's all we're pretty much doing on this. Now we're going to go over domain and range as well, because we had a little bit of trouble with that on our quiz yesterday. The biggest one was the vertical one you had trouble with, but I already did a video on that. Check that out. If you guys missed that on your quiz, definitely check out that video in your announcements. So regardless of the graph, I don't even care about the graph right now. I want you to look at your equations and tell me what happened on your equations. What did it do?
Moved right 4 and up 2.
Yeah. That's literally all you're doing. That's it. All right. So while we're here on this one, let's look at our domain and range. Get your domain and range. Look at this very first one. What's your domain? How far to the left? How far to the right? So here's your leftmost point. There are no arrows. There are no holes. So we should use brackets. What's your leftmost point?
Three.
What kind of 3? You guys are missing that as well.
-3.
-3, watch your signs. So if I put watch your signs on your quiz, that means you got a negative or a positive wrong somewhere. And then it has no holes as we go across all the way to what? Where do we finish up?
5.
5. Also a solid point. Okay. Look at your range. It says how low to how high. So here's our lowest point. Here's our highest point. So where is your, they're all solid, so brackets. Where's your lowest point?
-2.
What's your highest point?
+2.
And brackets, because there's no holes. That's it. Okay. All of these are normal graphs that we've seen before. Okay. They're not piecewise like this. We'll learn piecewise soon. All of these are the normal ones that we learned yesterday. What are all of their domains? They all have arrows on the left and right, correct?
Infinity.
Yeah.
Infinity positive.
Yep. Make sure that it's in parentheses because it's a direction, not a real number. And because they all have arrows, they're all going to be negative to positive infinity. What type of graph is this first one that I'm pointing at?
Linear.
Linear. So it goes up and down forever as well. So its range is also going to be negative to positive infinity. What type of graph is this U shape?
Quadratic.
So it's a quadratic. Now it has a boundary because it has a minimum point. Remember, we go lowest to highest, left to right. So what's your lowest point? No holes, so it's included.
0.
0. What's your highest point? How high does this graph go?
Infinity.
Perfect. All right, look at your next one. Also has a low point, also included because it's not a hole. What's the lowest point?
0.
Highest point?
Infinity.
Notice those two are pretty much the same. What type of graph is that one?
Absolute value.
Guys, on your test, you're gonna have to be able to know those, okay? So all of this stuff that I'm asking you right here, it's gonna be on your test. Look at the next one. Remember, this one's different. It does have a low point, but is that low point included?
No.
No, because it's an asymptote. It never touches it. Where is it at? Where does it never touch?
1.
Not 1. It crosses
Zero.
at 1, 0. Yeah. See, it crosses at 1, so we can't use 1. So it's wherever it doesn't touch. So this is going to be your asymptote. And then how high does it go?
Infinity.
And what type of graph is this?
Exponential.
Perfect. And then we're going to flip our page. Any questions on this? Okay, all of that line was just more review than anything. All right. Hold off on the writing equations. Nope, we're good. Is this the next page you guys have? I feel like I have it out of order. Y'all okay? Yep, we're good. Let's skip this page and go to the next one. This one's really quick because it's just describing translations. What would this one do? How would this one move? What's this?
Right 3 down.
Right 3, and you guys can write it like this, R3, D4. I'm happy with that. Don't stress yourself out. All right, what about G of X?
Left 2, up 3.
Is everybody good with that? All right, so now that's part A. That's basically what it wants you to do. Y'all got to stop emailing. We'll get there in a minute. So if you're emailing me or texting me, or I mean, not texting me, we don't text, emailing me or chatting me, I'm not checking that right now. So just give it a minute. Now what they want to do is describe the translation from f of x to g of x. So this is how I teach this. So on f of x, you said we went right 3, which is a positive 3, and down 4, which is a negative 4. Right 3, down 4. For g of x, you said we went left 2 and up 3. You just pulled out a new vertex, okay? Where we were using 0, 0, this is our new vertex. So when we get to this equation right here, our vertex, you said, is going to be left 2 and up 3. So negative 2, 3 is your new vertex for your U shape on that one. That's how easy it is. So that's why I was showing you all that vertex form. I'm going to graph these 2 points and show you, but then I'm going to show you how to do it without having to graph, because some of you won't graph because I'm lazy like that. I don't want to graph either. So I just do it in my head, but some of you need the visual. So here's the visual. 3, -4, and I'm going to put a little f of x there. And g of x is -2, 3. It wants to know how you get from f of x to g of x. So I only want straight lines. I only want straight lines. I'm going from f of x to g of x. What were the movements I made, up, down, left, right, and how far were they? So from f of x to g of x, what did I do? How did I move from f of x to g of x? And I made arrows, so I made it easy. What are your 2 directions you went in?
You went up
six,
7.
left, 5.
You went up and left, so you guys can see the arrows up and left, and then you counted the boxes. 1, 2, 3, 4, 5, 6, 7 up. 1, 2, 3, 4, 5 left. That's it. That's all you do. So if you graph it, it's very easy to see. Otherwise, think about a number line. Think about a number line and look at your x's. On your x-axis, you move left to right. How would I get from +3 to -2? What movement would that be? On the x-axis, from +3 to -2 on a number line.
Left.
To the left. So from 3 to -2, I can see that that's left. And then what is the distance on the number line? From 3 to -2 is 5 units. So you can look at your coordinates and do it as well. You don't have to graph it. So I'll graph a couple, but then I'll make sure that that I don't have to worry about doing it in my head too, or I can worry about doing it in my head. So then here on a number line on your y-axis, to get from -4 on the y-axis to +3 on the y-axis, I have to go up, and that's what you said, and the distance they are apart is 7. Okay, any questions there? Look at your next one. What's your vertex for your f of x? What's your vertex for your for your f of x?
-2, 3.
Change the inside, keep the outside. If I want to graph that, I can. -2, +3. I'm going to put my little f of x here. Somebody else, what's your vertex for g of x?
+5, -1.
Change x, keep y. So +5, 1, 2, 3, 4, 5, -1. How do I get from f of x to g of x? What are the movements that I took?
Right, then down.
And then what are the units? How far to the right did I go?
7.
Yeah, from -2 to +5 is 7 units. And then how far down did I go? From 3 to -1?
4.
Yeah, that's it. That's all you do. Okay, you can do it on the graph or you can figure it out from your coordinates. It doesn't matter. I don't have to see the graph. You don't have to show me, but you can graph it on your own. All right. Number 3, what's your coordinate for f of x? What's your coordinate?
-2, -4.
Change x, keep y. -2, -4. For your g of x, what's your coordinate?
+1, +3.
Change x, keep y, that's your g of x. How do I get from f of x to g of x? What were my 2 movements?
Up, then right.
Okay. Up and right. How far up?
Seven.
How far to the right?
Three.
Perfect. The other one is exactly the same. I'm not going to do it. I'm going to back up and go to the equations. The equations are the ones that are harder, but we already did equations today. That's why I wanted to start it. The only difference with these equations is you have new vertices. I'm not going to do all of these. I'm just going to do a few of them. Let's see. We can start real fast with this linear. What axis does this one go through, this very bottom one?
The y-axis.
And where does it go through it at?
2.
2. That's it. That's all you do on that. I'm going to hold off on these linear for a minute. If you get a linear graph, find the slope and the y-intercept. So I don't like these because they don't give you your y-intercept. I don't like these sketches. So again, find your slope and y-intercept. You don't need the 2 points. You can do the 2 points in your table if you want to. I don't care. That's fine. Or in your stat. You guys remember how to do stat? You can do stat calc, linear regression. You can do quadratic regression. You cannot do absolute value, but you can do exponential. So I don't care if you use your calculators on this, but I'm going to show you how to do it by hand. And I don't want to keep you too much longer, so I'm just going to show you one of each quickly. Okay, so remember our quadratic is y equals a times x plus 0 squared plus 0. But we have a new vertex now. What's our new vertex for quadratic? It's not at 0, 0 anymore. Where is this one at?
4, -3.
So then this becomes our x, our y, and this is our vertex. So listen carefully because this one and absolute value are pretty much exactly the same, okay? Your y coordinate that's going to fill this in is going to be -1. We are looking for a, so it'll stay a. What is your x coordinate?
6.
Yes, use that coordinate 6. Do not change that one. However, remember when we put in our vertex coordinate or we take it out, we change the sign. This one has to change. So our vertex x, we're going to change to a -4. Okay, that's the only one that you change. And then we finish it with our y coordinate, which is -3. Now it's just solving and clean it up. So the hardest part is the only thing you change is this. Don't change any other coordinate. So plug it in. What is 6 minus 4?
2.
Squared is
4.
4. So we get 4a minus 3. And again, that 4 comes from 6 minus 4 is 2. Squared is 4 times a is 4a. Add 3 to both sides because we're solving for a. We get 2 equals 4a. Divide by 4, and we get that a is 1/2. Again, check, is this positive or negative a? It's a positive graph, so it's a positive equation. So your equation for this one, and I'm going to write it up here, is going to be y equals, what did we get for a?
1/2.
And then you have to plug in your vertex. Leave your x. Your vertex is right here. Okay, so finish it out. -4 squared minus 3. Okay. -4 minus 3. Go over your linear absolute value. It's the same thing, except for its absolute value of x plus 0 plus 0. But you have a new vertex. This coordinate is your x and your y. This coordinate is your new vertex. So we're going to do our y coordinate. We're going to fill in this equation. Our y coordinate is 5. We don't know a. We're going to do absolute value of our x coordinate is 5. What do I have to do to my vertex x?
Switch the sign.
So it's going to be a -4. Finish out your absolute value. Your vertex y stays the same. It's a +2. Clean it, solve it, rewrite it. What's 5 minus 4?
1.
Absolute value of 1 is 1. It's always a positive. Absolute value is always positive. Times a is 1a. And then we have +2. Finish it out by subtracting 2. And we get 3 equals a. Write your equation. Leave the letters y and x in your equation. So y equals, we got 3 for a, absolute value, leave your x, and then rewrite the ending right here. -4, finish out your absolute value, +2. When you go to your exponential, you do the same thing. It's just a little bit trickier when you do it, okay? What I'm gonna do is leave the exponential. I don't think you have one on your quiz. I don't think you have one on your quiz. But I'm gonna leave the exponential as a calculator problem, okay? So I'm telling you, you can use exponential for your calculator because it makes it weird. So I'm going to show you those steps, and I will go back and record a video to show you how to do all of them on your calculator sometime today. Don't push for it. I have 2 more classes today, and then I have lunch from 12 to 1. So between the time that we finish right now and that, I will try to get those notes re-recorded that I didn't record before, and then I'll try to do this. So you go to math. I'm sorry, not to math. You go to stat and edit. And if there's stuff in here, you clear it out. Don't delete it, clear it. And I'm going to put in my 2 coordinates. The 2 coordinates they give me are 526 and 32. Okay, so I put those coordinates in. Make sure you read them just like that, 526, 32. And then I'm going to go back to stat, and I'm going to go to calc. If we were trying to do a linear equation, you could do linear. You can do quadratic for number 5. But this one is exponential, so we got to go down to 0. And then we did put it in L1, L2. That's all you need. And it'll give you that equation. And this is why I didn't want to do this one by hand, is because it's a really, really bad equation. So that's the equation for it. The way you would write it is y equals whatever your a is, 0.04. Parenthesis, your b was 3.61, and then to the x. So again, this is why I don't like these and why I say you can use your calculator. But if we go back to the other ones that I did earlier that I didn't record, I apologize. So like we found out that this one was 2 to the x. I can go into stat and edit and change my equation. I'm sorry, my point 38. And this one is 0, 1. So there's your coordinates into your table. Stat, calc, and we're doing exponential. And it'll give me that 1 and that 2. So 1 times 2 to the x. You guys can do it this way. It's fine on your tests, on your quizzes. I don't mind you doing it this way. The only thing I need by hand is the graphs. So if I ask you to graph one, I need you to graph it by hand. All right. So I'm going to stay on here. You can go off if you want to, if you're ready to go. But if you want to stay, I can't make you stay because we're at that max hour or whatever. You can go take your quiz. Otherwise, I'm going to go over a couple more of these to finish out these notes for you to watch. And then I'll go back and do those other ones. So these will be on the end of the notes. I'll be talking to myself. Probably going to do it on calculator for you, except for the linear absolute value as well as by hand. But again, if you want to leave, go ahead and leave. If you don't, I'm going to go back to these linear and start with those. And I'm going to show you the linear on the calculator. And then I'll show you the rest by hand. I will also show you a quadratic on the calculator, but you do the same thing. You just go to quadratic. So again, you're free to go. I'm going to go over these linear, how to do it on the calculator starting now. So stat, edit. Again, if you want to leave, you can leave. Otherwise, you can stay. My two coordinates, my x's are -3 and 1. My y's are -2 and 2. And then we're going to do stat, calc, linear regression, and calculate it. And our equation is ax plus b on the calculator, which means that our equation would be 1x plus 1, or just x plus 1. I'll accept either answer, and that's perfectly fine. Again, if we do the second one, we're going to go to stat and edit. Our two x coordinates are -2 and 3. Our two y coordinates are 5 and -2. Stat, calc, linear regression. And we get y equals, again, these are kind of crappy not to do on the calculator. You have to do them by hand, but I'm going to let you do them on the calculator. -1.4x plus 2.2. Okay. So that's all your linear. I'm going to do one quadratic on the calculator, and I'll do another one by hand. So I'm going to do the positive one on the calculator right here. And then I'll do the negative one by hand so that you see a positive and a negative one worked out. So again, you're going to stat and you're going to edit. Your two x's are -1 and 1. Your two y's are 2 and -4. You go to stat, over to calc, and this time we're doing a quadratic. So you have to know what function you're looking at. Finish it out and you get not crazy stuff. Hold on, let me see what happened. Stat, edit. -1, 2, 1, -4. I'm not sure what's going on. L1, L2, quadratic. Let's see. It's doing something weird. Let's do the other one and see what happens, and I'll do this one by hand. Stat, edit. If anybody else's calculator is not doing that, let me know. Or if I typed something in wrong. -1, -4, 3, -1, quadratic regression. Is anybody else's calculator doing that? Second plus 7.2. Give me a minute. Let's see what happens. Edit. Stop. -1, -4, 3, and -1.
So would fx be like a replacement for y?
Yeah, you can do f of x, and that's fine. I don't know why these are not working in the calculator. Oh, I think I need 3 points. I think I need 3 points. So let's just go ahead and do these by hand. I thought I just needed 2, but it may be that I need 3. I think I need the vertex and 1 point on either side. So this is going to be your vertex. And this is going to be your xy. So y is -1 equals a times your x coordinate, which is -4. And then your vertex, change the sign, +1 squared. Leave your y coordinate with your vertex. -4 plus 1 is -3. Squared is +9. So you get 9a plus 3. Subtract 3. -4 equals 9a. Divide by 9, and you get a equals -4/9. So your equation for this one, and I'm going to write it sideways, y equals -4/9. X and then follow through with this stuff. Plus 1 squared plus 3.
Thank you.
Yeah, absolutely. And then the next one, same thing. Our y coordinate and our x coordinate are up here. This is your vertex. So y is 2 equals a times x is -1. Change the vertex squared, keep the y. -1 minus 1 is -2. Squared is 4. So 4a minus 4. Add 4 to both sides. We get 6 equals 4a. Divide by 4 and you get 3/2. Be careful not to flip that fraction around. So your final answer would be y equals a positive 3/2 x. And then again, the vertex just brings down -1 squared minus 4.
Okay, I think that's all I needed.
Okay, no worries. Are you good with the absolute value? It's basically the same.
Yeah.
Okay, I'm going to keep going. You can go off, but I want to finish these notes so you guys can go back and reference them if you need them.
All right.
All right. So then absolute value, we're going to do, this is our vertex. This is our x and y. -5 equals, we don't know our a. Absolute value, our x coordinate is -5. Change your vertex, keep your y. Change your vertex x, keep your y. -5 plus 3 is -2. The absolute value is +2. So 2a plus 2. We're going to subtract our 2. We get -7 equals 2a. Divide by 2 and we get a equals -7/2. And it should be negative because it's flipped over. Your final equation, y equals -7/2, absolute value of x. And again, you're going to put the rest of this vertex in there, plus 3, absolute value plus 2. Then your last absolute value, this is your vertex, this is your x and y. So y is -1 equals a, absolute value, your x. Then do your vertex. This one is easy because it's a +0, so you don't have to forget to change the sign. It's already good for you. And then keep the y. -3 plus 0 is -3. The absolute value is +3 times a is 3a. Subtract your 4. You get -5 equals 3a. Divide by 3 and you get a equals -5/3, which you should because it's flipped over. Your final equation, y equals -5/3, absolute value of x. Finish it out with your +0 plus 4, or simplify it, -5/3, absolute value of x plus 4. And again, I'll show you those